Hey, welcome back everybody. So today we are going to be talking about prime factorization. Whew, sounds fancy, doesn't it? So you want to make sure that you have the notes so you can follow along with me as we go. All right, so prime factorization is actually going to take the two things that we were just talking about, factors and prime numbers, and put them together. Okay, so I have a cool fact for you. Did you know that every number can actually be broken down into prime numbers? And then whenever we write that as a multiplication expression, we call that the prime factorization. Okay, so this is a lot of big words. Let's jump right into it and see what this is going to look like. Okay, when we were listing factors, we were making rainbows. But now today, when we find the prime factors, we're actually going to use factor trees. Okay, it's a lot of nature we're talking about here, isn't it? All right, so I want you guys to come down here. We're going to do some examples. If we're going to find the prime factorization of a number like 24, okay, we're going to make a factor tree, so we're going to use branches. So do this with me. Start with 2 branches coming off the number 24. And you're going to ask yourself, what are some factors of 24? 2 numbers I can multiply to get 24. So I'm thinking 4 and 6. Okay, now there's a lot of factors of 24, but let's do this example with me for right now. Okay, so we're using 4 and 6. Now, are either of those numbers prime? No, they're not. So we're going to break them down. 2 numbers that are factors of 4 would be 2 and 2. Okay? Is 2 a prime number? Yes, it is. So I'm going to circle it because once it gets to be a prime number, I can't break it down anymore. Okay? The only way to break down 2 would be 1 times 2. And that's not going to be helpful. Okay? So when we get to a prime number, we circle it. Let's go back over here to 6. 6 can be broken down into 2 times 3. Is 2 a prime number? Yes. Is 3 a prime number? Yes. Okay, so we've got all prime numbers here. So we would say that the prime factorization of 24 is 2 times 2 times 2 times 3. Okay? You guys know that that dot is another symbol for multiplication, right? I think we've talked about that before. But if not, hey, that dot is a symbol of multiplication. Okay, then we can double check our answer by multiplying these prime factors, these prime numbers together. 2 times 2 is 4, 4 times 2 is 8, and 8 times 3 is 24, just what we started with. So when we find the prime factorization, we're taking the number and we're breaking it down, or you might think of it as rewriting it as prime factors, prime numbers that we're multiplying together. So this is the prime factorization. We have to make a factor tree to get the prime factorization. Okay? Here's a really cool thing about this. Okay, you guys don't have to do this on your paper, but I want you to watch what happens if I wouldn't have started with 4 and 6. Okay, maybe I would have started with 2 and 12 as the factors for 24. Okay, 2 we know is prime, so we circle it. Always circle your prime numbers. 12 is not prime, so I'm going to factor that down into 2 and 6. 2 is prime, 6 is not. So we have 2 and 3. 2 is prime, 3 is not, or 3 is also prime. So look at my factors here again. 2 times 2 times 2 times 3, which is exactly what we got the first time. So you can make your factor tree different from someone else, but you're still going to end up with the same prime factorization. Okay? You should always get the same prime factorization for your number. All right, let's go on. Do you see why we call it a factor tree? Yes. We have lots of branches. All right, next up, we have the number 45. So here we go. We're going to start with our 2 branches. Okay, remember you guys have your multiplication table that might help you come up with factors if you happen to get stuck. You also have your prime number chart on the back of your notes from section A1 that you could use if you're not sure if a number is prime or not. Okay, so 45, this number ends with a 5, so I know that 5 is going to be a factor, and 5 times 9 is 45. Okay, is 5 a prime number? It sure is. Is 9 a prime number? No. So we could do 3 times 3. Okay, those are each prime, so I'm going to circle them. Are you circling your prime numbers? If not, you should pause this video and go back and circle all your prime numbers. All right, here we go. So we make our factor tree to get the prime factorization. The prime factorization here would be 3 times 3 times 5. I always like to write them in order from least to greatest. It's just a good habit to get into. I wouldn't count it wrong if you didn't, but like I said, it's a good habit to get into. It might even be helpful to kind of draw a line through them as you're writing them so you know that you have them all. And always, 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 always multiply them out to make sure that they're equal to the number you started with. 3 times 3 is 9. 9 times 5 does equal 45, so I know that I'm right. Okay, you're going to pause this video and you're going to make a factor tree for 90 and find the prime factorization on your own, and then you're going to hit play and see if you agree. Alrighty, good luck. Okay, hopefully you came up with 2 times 3 times 3 times 5. Remember, those numbers could be in a different order, and it's still okay. Remember, when you write the prime factorization, you put the multiplication symbol in between the numbers. And remember that this part of your tree could look a little bit different from mine. Maybe you started out with 2 and 45. Okay, and that would work. You should still have gotten the same prime factorization that I did. All right, let me know if you have any questions. Otherwise, you're ready to go on to the practice.